This example illustrates how to plot a waveform that varies both in space, the x variable, and in time. I'll start by making sure the workspace is clear, and then defining some variables I'll need. These are the settings: the wavelength 20, the wave period is 12, the amplitude is 1, and I want to know how many data points I'm going to have. So I'm going to have 120 in the x and 80 in time. I'll start by constructing the x variable using the linspace command. So it's a regularly spaced variable between 0 and 3 times the wavelength with a total number of 120 points. I'll do the same thing for time, except this is going from 0 to the wave period t. Actually, we're doing 2 of those. And it's going to have nt points, which is 80. I'm transposing that to turn it into a column vector. The next step is I'm going to use mesh grid so that I have x and time pairs for every x and time point that I'm considering. So I see that x and time variables change from row and column vectors to full matrices. Now I'll define eta, my sea surface elevation, which is a cosine wave in x and time. So you can see the amplitude A times cosine 2 pi x divided by L minus 2 pi times time divided by the wave period t. And we can look at the variables using whos, but you can see it over on the right in the workspace anyway. Now I'll open figure 1, and I'll clear just to make sure nothing's there using CLF. And now I'm going to plot eta versus x, but at time equals 0, so just the first time. And I'll let Matlab figure out the line type it's going to use. We can add in x labels and y labels, and also turn the grid on. Now let's look at the figure. So what you can see here is we've got the cosine variability. X is on the horizontal axis, surface elevation is on the vertical axis. Now we can hold that line and add on lines from other times. And I'll just pick the 11th time first, and then also the 21st time. So I'm using the indexing to the matrix to do this. And MATLAB's going to pick the colors it wants. And it's worth adding a legend. Here, I'm going to add for the legend each associated time. And I'm using the num2 string or num2str function that you can look into. And now let's look at the figure. Now there are 3 curves, and there's the legend. So we've got it at time equals 0, roughly at time equals 3 seconds, and then the next one, the yellow, is time equals 6 seconds. So there are 3 different curves, and we can get a sense of the progression of the wave. It's propagating in the positive x direction. So now let's make a second figure, and we'll use CLF to clear it just in case there's anything there. And at this point, I'm going to just plot the first time again, just like before. And I'll put in the same x labels. Actually, I just arrowed up to get that. And now I'm going to write a small for loop. And what I'm going to do is I'm going to replace the y data that has eta from the first time with eta from subsequent times. I'm looping through from time, the second index, all the way through to the end of the times. And that h is the handle of the plot object, that line that's made. And I'm using the pause function, and this will pause activity until we move it forward by pressing spacebar or something else. We first see the surface elevation at time equals 0. As I press the spacebar, I'm sequencing through the times, and you can see the wave propagate in the positive x direction. I sped up how quickly I'm pressing the spacebar to make it animate more quickly. Now let's automate the animation by changing the pause to having an argument which is in seconds. So I'll just arrow up to get this for loop again, and I'll modify the pause, and in parentheses I'll put 0.1 seconds. And now it smoothly progresses through the animation. Now let's clear the variables h and t. We don't need them anymore, and it cleans up the workspace a little bit. Next, we'll make a new figure, figure 3, and we'll CLF that to make sure nothing's on it. And now we're going to make a surface plot with both x and time as our independent variables. So I'll use the surf command here, and it's surf x, time, eta. I'm going to use a different type of shading than standard. I'll use shading interp. And I'll set the c-axis, the color axis, to go between negative A and positive A. And let's have Matlab show a color bar for us too. We can add X labels and Y labels as before, but now this is actually going to have a Z axis too, so we'll label that appropriately. Here's the figure. You can see the x-axis, the time axis, and the elevation axis. And we can see that it's a three-dimensional surface really, and also it's color-coded as well, with the blues being the lower levels and the yellows being the higher levels. Here I've converted it to a two-dimensional view, but you can still get a sense of the higher and lower elevation because of the colors. And you can move the view any way you want really, and I'm using the rotation tool that's included on the window. And let's move it back to the way it originally was, or somewhere close to that. Now we can finish up by saving the data to a mat file. And those are the variables that are there. And after that, we could clear the workspace, removing all the variables. And then we could load them right back in. But now that we're done, I'll clear the workspace again. And we can close all the figures. And we can clean up the command window too, using CLC. So those are some ways to plot data that varies in both space and time.